is we're going to do a little bit of so 3.2, 3.3 homework. This might have been already due. Was this literally already due? Where am I at here? No, it's due tonight. So this assignment is technically due tonight. It looks like Mackenzie already turned it in, but so this is due tonight, right? And I just wanted to make sure that we're doing these correct. So, like number 9. So get this out really quick. So 3.2 to 3.3 homework. A few freebies just to make sure we're doing this right. So like number 9, for example, when you look at this, you should see that there's some like terms that are already on the same side. And so what you want to do is combine those right away. Again, they're already on the same side. And then once you get the m's together, then you can get m all by itself by dividing. So over here you get a 2, and so there's the final answer, m equals 2. Number 11, you look at this and you only see an x one time, but you do see these parentheses. So the very first thing you want to do is distribute and clear the parentheses. So 3 times 3x is 9x, and then 3 times negative 6 is minus 18. Now you can move on with the business of getting x all by itself. Because again, I don't see any like terms that are already on the same side, and I don't see an x term both on the right side and on the left side. There's nothing like that to do. So I just got to focus on getting x by itself. Now what you have to do is cancel out that first by adding 18 to both sides. So that's going to be 36 over there, and you'll be left with a 9x over here. Now you just have to divide both sides by 9 to finish getting x by itself. And you'll get x equals 4, I believe. Okay? So there's like a set of priorities, right? On the next page, let's do one of the big boys here. Like number 21. Let's do number 21 together. So in number 21, actually, would there be another one? We'll do 21, and then we'll also do 23, and we'll move on. So 21, the first thing I see to do here is clear the parentheses. Yes, I see a k over here as well as a k over here, but I'm not going to do anything until I clear the that's a very high priority, is clearing the parentheses. So I distribute the 8, and I get 32k minus 32. The right side just drops down. I'm just going to bring that down. Now I move on with getting the k's only on one side, because there's no like terms over here and there's no like terms over here that are already on the same side. So what I do is I move on to getting the k's only on one side. So I have to cancel that out from the right side. But if I add 5k to this side, I also have to add 5k to this side. So that's going to be a 37k over here. The minus 32 drops down. This minus 32 drops down. And then you move on. Like now you move on to like getting k all by itself. So I have to get rid of, again, getting k by itself is like all the stuff that's crowding around the k. Everything else that's on this left side, you're going to get rid of, starting with this minus 32. So we add 32 to both sides, and we get 37k equals 0. There's one more step, which is to like divide both sides by 37. And so you just end up with k equals 0, because 0 divided by 37 is just going to be 0. Okay? Number 23, once again, the very first thing you should do is what? clear the parentheses. So I distribute the 8 and I get that. I bring down the plus 5 and then I bring down the right side. Okay? Now you move on with like your priorities, you know what I mean? Do you see any, like the next priority would be if you see any like terms that are already on the same side together. That would be the 8 and the 5. So that's 13. Everything else sort of drops down, you know? And now you can continue with business, you know, like the very next thing we would do is, we got an X over here and an X over on the other side. I got to get them all on the same side by maybe doing this, like subtracting 5X away from this side over here to the other side. So this becomes 35X, and wow, not having a lot of room here, huh? But that drops down, and this 13, wow, this is going to end up being like very, very similar to number 21. But I'll let you finish this off, but because now that X is only on one side, now you have to just get the X all by itself. You have to get that 13 out of there, and then you have to cancel out that 35, you know, the same way we did in number 21. So I'll leave you to do that, but that's the homework. Does anyone have any, like, you know, fairly specific questions about anything else on this 3.2 to 3.3 homework? Anybody? Aaron's here. Elison's here. Jack, Jonathan, Dakaya. Is everyone good on the 3.2 to 3.3 homework? Alrighty. Well, then let's do, hopefully fairly quickly, these notes. So get out these notes, please. And hopefully we can make short work of this, because there are so many similarities to what we just got done talking about, like solving equations. You know, the only big thing we got now is it's inequalities, solving inequalities, solving multi-step inequalities. All right, so it's going to be very, very, very similar. Okay. There's going to be a couple differences, though, but hopefully we can kind of, you know, cut right to the chase a lot and kind of move through this very quickly. So a solution to an equation is any number or any value that replaces the variable to make the equation what, Aaron? Do you think you know what completes this blank here? A solution to an equation, any number that replaces the variable to make the equation what? Starts with a T.
I don't know.
True. That's okay. I mean, that's what a solution is. Okay? That's what a solution is. It's what you could replace the variable with to make the equation, you know, true. You know what I mean? Question, is that also true for solutions to inequalities like this? X minus 4 is less than 3. So inequalities are just, they're kind of like equations, but you don't have an equal sign anymore. You have a less than or a greater than, or like a less than or equal to, or a greater than or equal to. So these are what we're talking about when we're talking about the word inequalities, you know. So like, is 10 a solution? 10 minus 4 is less than 3. I don't think so. I think that's a no. Because 10 minus 4 is not less than 3. Is 6 a solution? 6 minus 4. Is that less than 3? Yes. Because if you replace the x with a 6, it does make this true. Ooh, here we go, Connor. Connor. Is 7 a solution? Is 7 minus 4 less than 3? What do you think, Connor? Any thoughts?
It's not.
Good. It's almost, right? Because if you plug in a 7, it makes it say 3 is less than 3, but 3 is not less than 3. 3 is equal to 3. So yeah, like 7 is not a solution. Okay? Now, if we wanted to represent all, because isn't there like a lot of solutions, right? Jack, how many, like obviously we only found 6, like 6 is a solution. But Jack, how many solutions are there really?
I don't know.
There's actually like infinitely many. There is an endless number of solutions that you could plug in for x to make whatever minus 4 just less than 3. It's just got to be less than 3. So think about like, couldn't you plug in like negative 1,000? Negative 1,000 less than, and then minus 4. That's going to be less than 3, you know? So if you think about it, I think you'll understand that there's an infinite number of answers. So what can we do? Like write them all down, you know? A common way is to like draw a graph. So that's okay. So solving inequalities compared to just solving equations, that's one major difference. With inequalities, there's not just going to be one answer. There's going to be like infinitely many. So it's very common to do like a graph. So here we go. Let's see here. So 3 is not a solution. Sorry, 7. What am I saying? So 7 was not a solution, but wouldn't anything less than 7 be a solution? Like 6 and 5 and 4, you know what I mean? All these would be solutions. But here's the thing, people, long story short. It's not just 6 and 5 and 4 and 3 and negative 6 and negative 20 and negative 1,000. It's literally everything less than 7. Like including 6.999999. Like 6.9, 6.99. So the way we actually graph this is we put an open, you're probably going to start finding this familiar. You put an open circle on 7 and you shade to the left, okay? Because here's what we're going to do. Here's what you really end up doing, okay? You get x by itself, just like you would do if that was an equal sign. So you would add 4 to both sides, and you would end up with x is less than 7. And this is your answer. All your answers are anything less than 7. So you'd put an open circle on 7 and you would shade to the left where everything that's less than 7 is. Compare that to this, where if you now got x by itself, by adding 4 to both sides, you would have x is less than or equal to 7. So 7, is 7 a solution? Yes. Because x can now be not only less than 7, but also equal to 7. That's what this symbol means. So we would put a closed circle, like we would actually color in 7, because now 7 is a part of our solutions. See here, we're technically not including 7 because it's like an open circle, you know what I mean? But here, we want to color in 7 as well as everything less than 7. So that's what's really happening. We want to color in, 2 and 5 and negative 1 and 6.5 and 6.999. But we also want to color in 7 because 7 is a solution because x can be less than or equal to 7. Turn to the back. So again, it's going to be just like you do with equations. Like here, Dakaya, 2x plus 5 is greater than or equal to 13. What's the first thing we would do to get x by itself? Subtract 2? Is that what you said? No. Eventually, we're going to divide both sides by 2. Because this says 2 times x, right? This says 2 times x. So to cancel that out, eventually we're going to be dividing by 2. But the first thing we got to get rid of is this adding 5, like plus 5. So we do the opposite of adding 5, which is subtracting 5. And so 13 minus 5, I believe, is 8. Now we get rid of that 2. And since this says 2 times x, doing the opposite is division. And so when we finally get x by itself, we end up with x is greater than or equal to 4. So all our solutions is everything bigger than or equal to 4. So we put a closed circle on 4 because of the or equal to line here. And then we shade to the right. Excuse me. So that's that example. In this example, same thing, right? We're just going to want to get x by itself, the same as what we would do if that was an equal sign. So a lot of this is just the same old skills. So the first thing we would do is what, Aaron? What's the first thing we would do to start to get x by itself here? Or to solve this inequality?
5 times x and then 5 times 1.
Yeah. It's a very high, we want to do this first. Like we pretty much always clear the parentheses first if there are any parentheses. So yeah, we distribute. And then the other side just comes on down. And then now what do we do, William? Do you know what we do next on our quest to solve for x?
You do minus 5 minus 3 to get like positive.
You do like this minus 5 and this minus 3? Is that what you're saying?
Yeah.
Okay. What you said, you're kind of like distorted there. So I don't know exactly what you said about it, but if you said that we're just going to combine the negative 5 and the negative 3, you can't combine them the way they are because they're not on the same side, We could get these numbers on the same side first, But what I usually say, so you're not necessarily wrong, but what I always sort of say you should do first is get the x's on the same side first. I think that's a pretty good way to go about things, is first get your x's together on the same side. And so, like I was saying about the negative 5 and the negative 3, you can't combine 4x and 5x together as is because they're not on the same side. So the first thing you have to do is subtract 4x away from the right side. Move it from the right side over here to the left side. And that's just going to be 1x or just x. And then I'm going to bring down the minus 5 and then the minus 3 over on the other side. See, now, William, now I know, okay, I got my x over here. And I want my numbers, like my regular numbers, to go to the other side. Because the left side is where I got my variable x. So now I got to get this minus 5 away from the left side over to the right side. So I'm going to add 5 to both sides. And so now I finish with x is greater than 2, because negative 3 plus 5 is 2. And so this is my final answer. x is greater than 2. These are all my solutions. X is greater than 2. But oftentimes you have to then draw the graph. So x is greater than 2. So I'm going to put an open circle on 2 because we just want everything that's greater than 2, not greater than or equal to 2, strictly greater than 2. So I'm going to shade to the right because that's where everything greater than 2 is. Now, slowing it down here for a second. Okay, slowing it down for just a second. I wonder if anybody here likes to use like this rule of thumb where, oh, you see how like this greater than is kind of like an arrow? It's kind of like an arrow pointed to the right, you know? I bet a few of you at least have heard about this like trick, this rule of thumb, where this is like an arrow that's pointed to the right, and so we shade to the right. Okay, that is a thing, but, this rule of thumb only works if your x is on the left. Okay? That rule of thumb where like this is like an arrow, this greater than is like an arrow pointing to the right, so you shade to the right. That only works if the variable is on the left. Just keep that in mind, okay? So that's something to keep in mind. Now, also sort of like recapping something. So final stretch, right? But before I do that, let me remind you of something. All this stuff, okay? Subtracting 5 from both sides and then dividing both sides by 2 and all this stuff of like getting x by itself. It's the same stuff whether it's an inequality, you know, like a greater than or equal to or a less than or equal to. You're still doing the same stuff to get x by itself that you would do if it was like an equation, like an equal sign. But like I already said on the, I said, okay, one difference is that you're not just going to have one answer, you're going to have infinitely many answers. And so you oftentimes have a graph of like your infinitely many answers. That's one difference. Okay, there's a lot of similarities, but that's one difference. The other major difference is this. The other major difference is, well, here we go. Let's see here. I don't know. Look, I'll just do it. Looking at this, I want to get x by itself. So the first thing I got to move out of there is the 4. Remember, that's a positive 4. So the way I get rid of that is subtracting 4, okay? So I'm going to subtract 4 to both sides. So that leaves a negative 3x on the left side. And on the right side, that's going to become a negative 12. All right. Dakaya, what's the next thing I would do to finish getting x by itself? What would I do to both sides?
Divide 3.
Divide both sides by not just 3, but it's a negative 3, right? So keep that in mind, everybody. If it's negative 3 times x, then you're going to be dividing both sides by negative 3. Okay, here's what you got to be on your toes about. With inequalities, with greater thans and less than or equal tos and greater than or equal tos, the other major difference that you got to keep in mind, that is a reality that you got to remember when it's not just an equal sign, but it's an inequality. Whenever you find yourself dividing or multiplying both sides by a negative number, like we're doing here, we are dividing both sides by a negative number. What you have to do is flip the symbol. Again, whenever you find yourself dividing both sides by something negative or multiplying both sides by something negative, on your way to getting x all by itself, you have to flip the symbol. It's just the way it goes. It's just the way it goes. Like, look, you'll see for yourself up here. We have this inequality that says 4 is less than 6. Pretty sure that's true. $4 is not as much as $6. So 4 is less than 6. If you multiply both sides by 2, you get 8 is less than 12, which is still true, right? That's still true. But if you multiply both sides by -2, you get -8 is less than -12, right? And guess what? That's just not true anymore. It's just not true anymore, you know? So no, that's not true. Again, it's just the way negatives are. Like if you were to divide both sides by 2, you'd get 2 is less than 3, which is still true. But if you divide both sides by -2, you get -2 is less than -3, which again, it's just not true anymore. And that's just the way negatives are, you know, like -3 is actually not bigger than -2. -2 is the one that's bigger, you know, and again, for like the third time I'm saying this, it's just the way negatives are. So for that reason, if you want to keep this true, you have to flip the symbol. So that's the other big thing you got to keep in mind, that it's like one of the two big differences between solving equations and solving inequalities. But x is now by itself, and then -12 divided by -3 is +4. And so now you just got to graph this. I mean, this is the answer, but you just got to graph it now. And so we put, what kind of circle on 4, William? Closed or open?
Closed.
Very good. And Jack, which way do we shade, left or right?
Left.
Very good. And that's all she wrote, huh? All right, so that's that for the notes. I believe my plan is, and I don't see myself changing my mind. My plan is for like these notes, which you guys have already got done, you know, like it's literally done as of now. So you can just go ahead and like turn these in. I think this is going to be like the very last assignment that's going to go in the grade book for this grading period, which ends next Thursday, like a week from tomorrow. So the grading period ends a week from tomorrow. So this notes assignment will be the last thing that will go in the grade book for that, right? Now, obviously, when we get back together again on Tuesday and Wednesday, we're going to be doing stuff, but it's gonna go on like next grading quarter's grades, okay, in next quarter's grade book. So the homework for this, I might not even post it yet. Like, when we come back from the Easter weekend, we might, start by just, whatever, like talking about like this, the homework assignment for this stuff. But anyway, so I guess that's it.